In the series so far, we've been looking at the paranormal and trying to show that current physics is no longer outraged by some of its strange results. But in this program, I want to look at some really new physics, which, although it's not yet fully accepted, may help us go further than that and get an idea as to how the paranormal might work.
Kit, when you say that current physics is no longer outraged by the idea of the paranormal, does that mean that we're getting somewhere towards some sort of theory that might actually explain it?
Well, a little way towards it, yes. You see, if the new physics is saying that pieces of matter, which appear to us to be separate in space, are actually connected, and in the series so far we've been talking about minds being connected in the same sort of way, then we better just look at how minds acquire information.
Well, one acquires information by learning or being taught.
Yes, that's true, but people are now beginning to think that there are two ways of acquiring information. First of all, in the everyday sense reality, that mind is separate from the universe around it. But in the other way of thinking, people are saying there's a sort of unity between the two minds. There's some sort of whole surrounding it all. And in that, there's no real problem about mind-to-mind communication, or indeed communication between mind and matter.
But Kit, while I accept that there are the two views, surely they are by definition mutually exclusive. You can't have them both at the same time.
Well, remember, earlier on we looked at some physics which said whatever you experiment on, you tend to get. Remember the beam of light? We showed that one beam of light can be both particles and waves at the same time. Now, some people are beginning to think that the mind, by the same token, can be two things at the same time.
Now, that experiment demonstrated the principle of complementarity, and you've brought it up now. This is the third time in this series. Therefore, I can only deduce from that that it is of extreme importance. Check me out, see if I've got it right so far. That experiment proves that a beam of light, when shown through a prism, can be something made up of wavelengths. If you fire it at a charged plate, it indicates that it's particles. Now, these aren't the properties of light. It is all depends on what you want to prove. It's the way you look at it. Now, if the light experiment proves that, am I right in thinking then that what you're trying to say is that it is perfectly possible for one mind in the universe, which believes that cause always precedes effect, that the whole thing is very hard-edged, to coexist perfectly well with another mind that takes the view that the universe is a much more fluid thing, in which there could be a mind-to-mind communication through some means that we don't know about, and that those two things can coexist, right?
Yes, it's almost as if there are two entirely different ways the mind can relate to reality outside it. Some people call this the complementarity of the mind. And one person who's studying it is living in New York. He's an experimental psychologist, and his name is Dr. Lawrence LeShan.
You know, perhaps the best analogy is how we get from one place to another. If we are going on a ship or an airplane and going a long distance, we have to take into account the fact that the Earth is curved, and some paths are faster than others, as a great circle route from England to the United States. But if I'm walking from one street to another, I better assume the world is flat and go along as if it's flat. That's the common sense way, because for me at that point it is flat. And so we can have two different ways of dealing with the world, which are non-contradictory.
This is what you call the clairvoyance and the sensory reality,
That's
isn't
right.
it? Yes.
The clairvoyant reality being the way of the relativity physicist, the way of the one of the mystics, and the way that the psychics use.
Dr. LeShan developed these two ideas of reality. The first one was a sensory reality, in which everything is, as it were, out there and separate.
Now, that's our idea of everyday reality, right?
Yes, this sort of reality like that. But he also talks about a clairvoyant reality in which everything tends to be unified and whole, in which the mind is embedded. Now, the reason why he did this was because all the people who claimed paranormal ability kept on saying to him that when they acquired paranormal information, it appeared to them that the universe around them changed.
Very persuasive, Kit, and I'm sure it's a very elegant solution to an otherwise insoluble philosophical problem, if you like. But where is there the evidence that this kind of connection exists for the people who do believe in the clairvoyant reality?
Yes, one physicist we'll be meeting in a minute tends to think that the basic unit of the universe is information itself. And funnily enough, he actually used a television example of this to show how it works. Over there, there's a goldfish in a tank. And we've got two television cameras, one looking at it from the side of the tank and the other looking at it end on. Now, each picture from each camera is coming through to these two monitors here.
Right.
And what we see on the two monitors is a picture of the goldfish there and a picture of the goldfish there. Now, what we're seeing, in fact, as one picture, as it were, changes into the other when the goldfish moves, we're seeing two objects which are separate in space but are connected by information.
Yeah, but so what? That's just a bit of television.
Right. Now, supposing instead we were out in deep space and we were scientists looking at something new, and all we were looking at were these two screens. We didn't know anything about television at all. We knew nothing about all the cameras and that sort of thing. All we could see were these two things. What we would correctly observe is we're seeing two systems, if you like, which are separate in space, but since one merges into the other and the other can merge into the one, we're seeing two separate systems, separate in space, connected together.
I see. So we're on the bridge of the Starship Enterprise and we switch on our monitors and see two pictures of deep space goldfish, and having got over our surprise, because one of them merges into the other, we conclude that we have two pictures of the same thing that are connected in some way, although the pictures themselves are separate. That's an illustration, that's not an experiment.
Well, let me show you an experiment.
Well, this is a lovely thing, Kit. What is it?
Well, it's a very dangerous machine. It's a double ping-pong ball projector. And it works like this. If I press the trigger, it fires one ping-pong ball in that direction and another in that.
Wow. Or even two or three.
Yes. Now, I think you'd agree that once one ping-pong ball has left the barrel here, and another one has left the barrel there, there's nothing I can do to that one which will affect this one once they're in flight.
Fair enough, yes.
Well, let's use an example. Pick up the ping-pong bat and hang it in the way of the ping-pong ball. Now, as that ping-pong ball came out of there and hit the bat, it deflected.
Yeah.
But it had no effect on this one, which continued on in its path undisturbed.
Absolutely right.
Right. Now let's get it turned off. Now that was a ping-pong ball projector. Now look at a pair of cannon. And if you replace the double ping-pong ball projector with two cannons and fire two cannonballs, nothing you can do to one cannonball once it's left the barrel will affect the other. If you put a bit of felt in the way of one cannonball and fire the guns again, even though one cannonball is slowed by the felt, it doesn't affect the path of the other. If you put a steel plate in the way and fire the guns yet again, one cannonball will bounce off the steel plate, the other will go on unaffected. Now forget the cannonballs and look instead at two elementary particles, which are the smallest part of an atom. If you fire two of them in opposite directions from a special gun, each one can be given a spin like a cricket ball. But if you put a magnet in the path of one of them, something really strange happens.
What happens? What goes on?
Well, one particle comes out of one projector, the other comes out of the other. They're going in opposing directions. The magnet makes this one change its spin in mid-flight, and the really strange thing that happens is, directly that happens, this one over here, downrange as it were, changes direction instantly.
You are seriously trying to tell me that two particles moving away from each other with opposite spins on, one of them goes through a magnet and changes the spin, and at the same time the other one changes its spin. How do they know it happens?
Well, there have been 8 experiments on this particular thing now, and 6 out of the 8 have confirmed that it does happen, yes.
In which case, the really important question, it seems to me, must be, how does this particle know what that particle is doing?
Well, there's a very hot debate about this in physics. It's by no means resolved, but either they say the whole of physics is wrong, there's no real evidence for that, or information gets around the place faster than light. Or, and this is the most favoured explanation at the moment, things which are separate in space to our senses actually are connected somewhere else, in some other part of the universe.
So where is this connection then?
Well, let me show you an example. Well, over here we've got an ordinary film projector, and if you switch it on, I'll show you what I mean. Over there's a picture of me on the screen. That is a stable, external, certain sensory reality.
Right.
But in here, in the heart of the machine, there's a racing flood of information roaring through the gate of the projector at 24 frames a second. That is an example, perhaps, of the hidden reality, hidden away from our senses, but which is connected to the real reality by information.
I see. Let me just see if I've grasped this so far. The fact that when you shoot the particles out of both ends of our particle gun with spin on, and this one goes through a magnet, which changes the spin, and instantaneously the spin on the other one, which, in theory at least, should not be connected in any way, changes, means three things. Either physics is wrong as we know it, or something travels faster than light, or, in some odd way, these particles have access to a kind of, what, a universal information store, rather like the information that's going through the gate on the projector at 24 frames a second, which at present we can't easily get into. Now, if that contention is right, is this universal information store where the paranormal is then?
No, that's probably going too far, but what it does do is to provide a concept, an idea, a framework of thinking in which it's really possible. But one man who's actually been working in the physics of this, not the paranormal part, but the physics, is Professor David Bohm of the University of London.
Yes, if you say that all matter actually works from information, not merely matter in the nervous system or matter, DNA matter working in the cell, but say even the electron is forming from empty space, being informed, as it were, by some unknown source of information, which may be all over this space. And then we can now say that there's no sharp division between thought, emotion, and matter. You see that they flow into each other. You see, even in ordinary experience, a thought and an emotion flow into a movement of matter in the body, or the movement of matter in the body gives rise to emotion and thought. Right? Now, the only point is, at present, science has no idea whatsoever of how thought could directly affect an object which is not in contact with the body, you see, or electrically through some system. But
this is really a very important point to make.
But if you say that the entire ground of existence is enfolded in space, that all matter is coming out of that space, including ourselves, our brains, our thoughts, and the thing you want to bend, then the information might readily pervade the space, so that matter starts to, you could say matter is always forming according to whatever information it has, and therefore the thought process could alter that information content. So I'd say that it does look possible, though I think very careful experiments have to be done before we say whether it actually does take place.
Kit, Professor Bohm is universally regarded as one of the most eminent living physicists, and I'm bound to say that what he's just said strikes me as the sort of thing I ought to go away for about a month and try and work out. But am I right in thinking that his view of the universe is that it is a kind of enormous groundswell of information, that there's information just hanging about all over the place, and that what we understand matter to be is the result of various bits of that information being projected out of this groundswell and coming together, and that's what matter consists of. Do we go on from that then, or does he go on from that to say that because the human mind, if you like, is a huge information store like a computer, and it must be pretty big, that we similarly can make other things happen by projecting bits of information from the mind? Is that what he's saying?
That's exactly what he's saying. And another person who's thinking in the same sort of way, that matter is connected with information which is connected with the mind, is Professor Josephson, who's a professor of physics in the University of Cambridge.
Yes, well, let me give you an example of what I mean. If I say to you, pass the salt, please.
All right.
Then what's happened is you've heard my voice, and then you passed the salt. Now, the energy in the sound of my voice is a very small amount of energy, and it became amplified into a much larger effect, and that's the sort of thing I'm interested in.
You're saying a sound signal produced the movement of metal, in a sense?
Yes.
But that's on a large scale, isn't it? Is it possible that this sort of thing could happen on a very small scale, the atomic scale, perhaps?
Well, if it can happen on one scale, it can happen on any other scale. So in principle, that can happen as well.
Yes. But here you seem to be saying, if I got it right, that your will, in terms of the salt cellar, moved the salt cellar. Now, are we talking about the will or the mind of somebody having an effect on atoms? Is that conceivable within the realm of physics?
Well, it's conceivable, yes.
So what Professor Josephson is saying once again is the information in the signal past the salt affects the movement of the salt cellar. So again, he's linking the idea of information being connected with matter. And I also asked Professor Geoffrey Chew of the University of California in Berkeley whether he thought that physicists would now take an increasing interest in this connection between the conscious mind and the physical world.
I think that's quite possible. I don't myself have any specific ideas in that direction, although I know that many of my colleagues are working in that direction. But to me, the complexity of the human might very well be an ingredient in the full story. It is it's a difficult thing for me to try to predict how long it will take before such a step might be made in which the complexity of the observer is really integrated into the understanding of what reality means, but I believe it will come. I believe it is going to happen.
Kit, Professor Chew is another physicist of great eminence. We take that as common ground, and yet here we have a man who is talking about the mind of the observer being involved in our understanding of reality. Now that surely has got to be an incredibly dangerous road for what, after all, has traditionally been a nice hard-edged science to go down. I mean, if you start on that, surely you'll have physicists try to explain God next. I mean, you're involving them in mystical experiences. This has got to be pretty close to being crazy.
Well, you remember we talked earlier on to Dr. Lawrence LeShan, the psychologist. Well, he did a very interesting experiment in this area. What he did was to take 60 descriptions of the universe, 30 were from high-energy physicists, and 30 were from mystics. He then took out of those descriptions key words like electron or Buddha, so give the game away.
Yeah.
And he gave the descriptions to a group of people and said, all right, who wrote which? And nobody could tell. The descriptions of the universe by the mystic were always the same as the description of the universe by the physicist. So, let's try the game on you.
All right.
Somebody, mystic or physicist, wrote this. The universe looks less and less like a great machine and more like a great thought.
That is a kind of mystical statement, I would
Well,
say.
it's Sir James Jeans, physicist. What about this one? Pure logical thinking cannot yield us any knowledge of the empirical world. All knowledge of reality starts from experience and ends in it. Propositions arrived at by purely logical means are completely empty of reality. Now, who wrote that, mystic or physicist?
That is a very tough one. That sounds rather unscientific, but of the same... Yes, I would say it's a sort of philosopher. I would put him in the mystic category.
Was Albert Einstein, physicist, who wrote this. It's necessary, therefore, that advancing knowledge should be based upon a clear, pure, and disciplined intellect. Mystic or physicist?
That's a clear, pure, and disciplined statement. That was from a scientist, a physicist.
Well, actually, it was from a mystic called Sri Aurobindo. Well, all right, this began to worry me too. So what I did, I went to talk to Brian Josephson about it.
Well, the ideal sort of way would be if a physicist himself had mystical experiences. And if he could do that, he could then try and incorporate those into his physics.
Yes. But it seems puzzling, doesn't it, to be able even to conceive the idea of incorporating mystical experience into what people would regard as being a very hard subject like physics.
Well, physics is really the most universal of the sciences. It is supposed, in principle, to cover every kind of phenomenon.
So you really are seeing no outrage in trying to connect one to the other.
Well, there's, in a sense, because mystical experience is a subjective experience, and physics is often thought of as being about things out there rather than things in the mind. But the distinction between what's outside us and what's inside us has got a little bit blurred in modern physics.
But the point is, Kit, surely, what's the point in it? For as long as physics was about what I call useful, handy things like inventing batteries, there was some material benefit for all the rest of us. But where do we benefit from a physicist having a mystical experience?
Well, let me say, first of all, The physicists who are thinking like that have no intention at all of abandoning logic, reason, and test by experiment. What they are saying is that this extended way of thinking brings the human condition into science. It's an optimistic sort of way of looking at things. One person I talked to, actually, who has views on this is Dr. Charles Tart.
Now, if you accept the reality of a phenomenon like telepathy, there is a very real sense in which you and I are one, that it's possible to have a very direct kind of contact. And in that case, I have much more real concern for what happens to you, whether you're happy or suffering, than if you're really forever isolated from me. Well, those kind of implications are very exciting. They will have effects on how we treat one another, how we view our place in the universe, how we relate to other animals, other life forms, and so forth. That's what's important.
Now, Dr. Tart is an experimental psychologist, and you'd naturally expect him to be more concerned with the affairs of the brain and mind. But Professor Elizabeth Rauscher, who we already met in Program 1, is an astrophysicist.
I think it's very optimistic. I personally think that it is something that will give us a handle on really understanding our interconnectedness with other people, with other things in the universe. Actually, we have a sense of separateness, but there also is always an example of the idea we're communicating. That's what we're doing now. There must be some connection or I can't communicate.
And in fact, other physicists working in the area are beginning to include the idea of mind and consciousness in their experimental work. And one of these is Dr. Fritjof Capra.
So you have these two realities, patterns of matter and patterns of mind, and the two reflect one another. You cannot say mind over matter or matter over mind. It's not that one causes the other, but they are mutually interrelated and reflect one another. And therefore, many physicists, including myself, think now that future progress in physics will not be possible unless we include the nature of consciousness explicitly in our theories. But as I just said before, there we go far beyond the current framework of science, and the new type of science will have to enter the picture.
What I found was that it was the physicists of all people who were prepared to shift their ground. Their view was often strikingly more flexible than the scientists working in the field of the paranormal. Professor Geoffrey Chew.
I think that's fair. I think that it's impossible for a person to study the great discoveries of the 20th century in relativity and quantum mechanics and not be led to this broader view. It is paradoxical that philosophers even are probably less willing on the whole to think in these extremely broad terms than physicists. Yeah. But it's true. I have discovered that, generally speaking, physicists are more willing to loosen their ways of thinking.
Well, Tony, you've been with the series since the beginning asking questions. What do you think now?
Well, that last section there really answered the last question I asked. I mean, Dr. Chew and the others really do regard this as enormously optimistic. It's work that is much more about people. It's much more optimistic than, for instance, the hydrogen bomb, and it's more about people than, say, Boyle's law or a battery. But going right back to the beginning, when I said to you all those months ago, is there any way in which science can explain the paranormal? I had in mind that you would somehow produce a kind of pat explanation for or against with experiments. I did not realize that if there were an explanation, then it might be found within science itself. That's impressed me. Now, you go on the record. What's your conclusion?
Well, one thing we all discovered while we were making the series is that nobody is neutral about the subject. Everybody has a view. Some people reject it outright, and others accept it fully. What I have tried to show you is that the paranormal is no longer the province of cranks. It's studied by ordinary scientists doing careful experiments in ordinary laboratories. It's only their results which are extraordinary. I'm sure it's an important step forward that over 35 colleges in the United States now teach formal courses in the paranormal, and the American Association for the Advancement of Science now recognizes it as part of the scientific endeavor. And so finally, my own view. I think a scientist would have to be massively ignorant or a confirmed bigot to deny the evidence that the mind can make connections with space, time, and matter in ways which probably have nothing to do with the ordinary senses. And also he'd find it difficult to deny that these strange effects are compatible with current thinking in physics. and may in the future become part of an extended science, in which they're no longer viewed as paranormal, but as normal.
These programs have raised a number of major implications for us all. We'll be discussing some of them in the last of this series.
Kit Pedler's book Mind Over Matter is written to accompany the series. Published by Thames Methuen and now in your bookshop, it costs £7.95.